Hello, everyone. I wanted to make you some videos to help with the topics that are optional in homework 11. This one will help you with the domain of a logarithmic function advanced. So let's talk about the domain of a logarithmic function. Now, we mentioned this in a previous video, but I just want to remind you that logarithmic functions are inverses of exponential functions. So an exponential function looks like this. And remember, the range of an exponential function was 0 to infinity. That means that the y values have to be strictly greater than 0. You can't get a y value that takes on any value except for 0 to infinity, and it does not include 0. Now, with logarithmic functions, we have y equals log base b of x. And remember, in an inverse function, your y and your x are backwards. So this x that's in here is actually the thing that came out of my exponential function. And so basically that means here that this x value that goes, the thing inside your logarithm, has to be greater than 0 because it's an output of an exponential. Your input of a logarithmic is the output of an exponential. So the input of a logarithmic function has to be greater than 0. Now, what does that mean for domain? Well, we're going to add a domain rule. If you have the log base b of some stuff, again, I don't care what your base is. It can be any base of a logarithm that you want. And if you have any kind of stuff inside a logarithm, we have to make sure that the stuff inside our logarithm is strictly greater than 0. Again, that's because the input here has to be greater than 0. The stuff inside needs to be greater than 0. And then once you set your stuff greater than 0, this is going to be an inequality that you can solve. We've covered a lot of different inequalities so far this term. We've done linear inequalities, quadratic inequalities, polynomial inequalities, and rational inequalities. We've done all of those. Basically, when in doubt, I want you to solve the equation and put those things on a number line and test values. That's kind of, um, you can only use the inequality and solve it with an inequality if you have a linear inequality. Other than that, you are solving the equation, putting those solutions on a number line and testing some values. Okay, so let's try this. So number one, we want to find the domain of these functions. So number one here, f of x equals log of the square root of 2x plus 3. So if we have stuff inside our logarithm, right, our stuff is the square root of 2x plus 3. We got to make sure that our stuff is strictly greater than 0. Okay, so to start solving this, we got to get rid of that square root. So we're going to square both sides. When we do that, we get 2x plus 3 over here. That's got to be greater than 0. And so now we're going to subtract 3 from both sides. 2x is greater than negative 3. And we're dividing by 2. So we've got x left over here, negative 3 halves over here. I'm dividing by a positive number, so we do not flip our inequality symbol. It's whether you're multiplying or dividing by a negative number. That's when you flip it. But the number we're dividing by is positive, so we're going to leave it be. And so because this was a linear inequality here, we can solve it with the inequality symbol. So our solutions here are x can be greater than negative 3 halves. It wants us to write our answer in interval notation. So x is greater than negative 3 halves. Looks like negative 3 halves up to infinity. And this does not have an equal sign on it, so we are going to leave that open. And that is the domain of this function. All right, let's try number 2. G of x equals log base 2 of 5 over x plus 4. Okay, we've got a logarithmic function. Doesn't matter what your base is. We've got stuff inside our logarithm. So we are going to take our stuff and set it greater than 0. Now we have to figure out how to solve this inequality. This is a rational inequality, which we did in homework 10. So to solve a rational inequality, you're going to get a 0 on one side, a single fraction on the other side, which we have. This is in the right format. We're going to set the top and the bottom equal to 0, and those are the solutions we're going to put on our number line. So if we set the top equal to 0, 5 equals 0. That's not true. 5 is never equal to 0. Well, that means we don't get any solutions from there to put on our number line. Don't panic. And so nothing on our number line from the top. We also need to set the bottom equal to 0, and that means x equals -4. That's the only solution we got. That's the one we're putting on our number line, and we're going to test values from there. So -4 goes on our number line. We chop it right here. And when we do, we've got 2 pieces, and we're going to pick a test value from each piece. My favorite number less than -4 is -5. And my favorite number greater than -4 is 1. Okay, so now I'm going to test my values, and we are going to test them in the inequality. This is the one we're trying to solve. This is where we're testing those values. So when I plug x equals -5 in, I get 5 over -5 plus 4. My inequality says that should be greater than 0. Okay, 5 divided by -5 plus 4, that's -1. 5 divided by -1 is -5, and my inequality says that's greater than 0. But -5 is not greater than 0. So that part doesn't work. All right, let's test the other part. If I plug 1 in, I'm going to have 5 divided by 1 plus 4. My inequality says that should be greater than 0. This is 5 divided by 5. 5 divided by 5 is 1. My inequality says that should be greater than 0. And it is. So this section works. I've tested all of our sections, and so now I can write the solutions. So everything bigger than -4 works. So I'm going to have -4 to infinity. We never include infinity. And -4 came from the bottom of my rational, so I definitely can't include it. But I don't have an equal sign in my inequality anyway, so we wouldn't include it anyway. So -4 to infinity, not including -4. Okay, let's do the next one. The h of x equals the natural log of 1 minus x squared. So ln here, this is actually a logarithm. ln means log base e of 1 minus x squared. I haven't really covered this in any of these videos yet. E is the natural number. It's Euler's number. It's kind of like pi. It's a number with a value of 2.18287, continuing on forever. It's about 2.7-ish. And so ln is log base e. It's still a log with a base. So we don't care what our base is. We've got stuff inside a logarithm. So to find our domain, we're going to take our stuff and we're going to set it greater than 0. Now, to solve this inequality, this is a quadratic inequality. And so to solve a quadratic inequality, we are going to solve the equation, put those values on a number line, and test our values. So to solve 1 minus x squared equals 0, you can factor this left side as a difference of squares. 1 minus x squared is 1 plus x, 1 minus x equals 0. Set each factor equal to 0, so either 1 plus x equals 0 or 1 minus x equals 0. So that means x equals -1 or x equals 1. Those are our 2 solutions that we'll put on a number line. If you wanted to, you could also add x squared up here and then take the square root of both sides. Just don't forget your plus and minus to get these two values. Once we get these two solutions, we're going to put them on a number line. And we are going to test values. So I'm just going to pick some numbers here. X equals -3, x equals 0, and x equals 2. And again, I'm plugging them in my inequality to test them. So when I do this, I'm going to get 1 minus -3 squared. My inequality says that should be greater than 0. So the first thing I have to do is my exponent. -3 squared is -3 times -3. That's 9. So I'm going to have 1 minus 9 is greater than 0. 1 minus 9 is -8. My inequality says that's greater than 0. Ooh, but -8 is definitely not greater than 0, so that doesn't work. Let's try the next one. 1 minus 0 squared. My inequality says that should be greater than 0. 0 squared is 0. 1 minus 0 is 1. That is, in fact, greater than 0, so that works. And finally, if x is 2, we get 1 minus 2 squared. My inequality says that should be greater than 0. I'm going to do my exponent first. 2 squared is 4, so I'm going to have 1 minus 4. My inequality says that should be greater than 0. 1 minus 4 is -3. That's not greater than 0, so that part doesn't work. All right, so overall, what works is the stuff in here between -1 and 1. So the stuff between -1 and 1 works. And to figure out whether we include our endpoints, we're going to come back and look at our inequality. We do not have a little equal sign there, so we are going to leave parentheses on both sides, and that is our solution. All right, last one here. R of x equals ln of x squared plus 1. Again, ln means log base e. For right now, the only thing that we need to know about that is that ln is, in fact, a logarithm. So I've got stuff inside a log. If you got stuff inside a log, you're going to set your stuff greater than 0 and solve this inequality. This, again, is a quadratic inequality, so we're going to solve the equation, put those solutions on a number line, and test our values. This is a sum of squares. I can't factor that. So I'm going to move that -1 to the other side. And this says x squared equals -1. That's saying I'm taking a number times itself and getting a -1 out of that. That's not possible. This thing doesn't have any solutions. I'm never going to be able to take a number times itself and get -1 out. So that means I don't have any solutions to put on my number line. What that means is that the whole number line is either going to work or it's not going to work. So you can pick any value that you want to on that number line, and we're going to test it to see if everything works or if nothing works. So the value that I want to plug in is 5. So I'm going to take x equals 5 and plug it in and see if it works. So I have 5 squared plus 1 is greater than 0. 5 squared is 25. Plus 1 is 26. That is most certainly greater than 0, which means my number line is going to work. That means everything on that number line works, and the solutions that work in here, the domain of this thing is -infinity to infinity. You can plug anything you want into this, and it's going to work just fine. All right, that is how you find the domain of logarithms. It's the stuff inside your log has to be greater than 0, and then fight through those inequalities with the methods that we've learned so far. All right, I hope you enjoy, and I will see you next time.